Welcome back to Cosmic Galaxy. In this video, we're discussing how to use the James Webb Space Telescope to hunt for life around white dwarfs. Make sure to like the video, subscribe to the channel, and hit the bell icon. White dwarfs, which are the remnant cores of sun-like stars, are extremely common in the universe. Many of them are home to planets that may be within their stars' habitable zones and may even support life. Scientists have now outlined how to search for that possible life. The total number of planets in the Milky Way is estimated to be between a few hundred billion and a trillion. That's right, $1 trillion. However, because finding planets in general is difficult, astronomers have only been able to confirm the existence of a few thousand. Almost all of the exoplanets discovered orbit stars with masses similar to the Sun. This is due to a number of factors. 1. We're looking for planets around sun-like stars in the hopes of finding life similar to our own. 2. Sun-like stars are extremely common. 3rd, while smaller red dwarf stars are more common than sun-like stars, they are much brighter, making it more difficult to find planets. Over 99.9% of the stars with planets will eventually evolve into white dwarfs, which are Earth-sized carbon and oxygen cores. Because sun-like stars are common and sun-like stars evolve into white dwarfs, there should be a plethora of planets orbiting white dwarfs. However, observations there have been limited, with only a few exotic examples. One is WD-0806-661b, a gas giant planet nearly 8 times the mass of Jupiter that orbits its white dwarf star at a distance of over 2,500 astronomical units, or 373.7 billion kilometers, taking more than 158,840 Earth years to complete one orbit. Anyone interested in finding exoplanets around white dwarfs faces 2 challenges. For one thing, they're very small and dim, so the commonly used transit method of staring at a star and waiting for the exoplanet to pass in front of it doesn't work. 2. Because white dwarfs' spectra lack prominent features, the other popular method, which involves observing the redshift and blueshift of spectral features as an orbiting planet tugs on its parent star, also fails. Another difficult question is whether planets can survive after their host star dies and becomes a red dwarf. The demise of a sun-like star is not pleasant. First, the star swells to become a red giant as it consumes planets that orbit too closely. It then goes through violent spasms that last millions of years, ejecting huge plumes of material into the surrounding system and destabilizing the other worlds. Even after all that violence, it's possible that a white dwarf could end up with planets. Some planets may be far enough away to avoid the destruction, allowing them to remain in their current orbits. Interactions between those planets and newly ejected material from the star have the potential to bring them closer together. Another mechanism is for the new planets to form from the wreckage of old ones, resulting in the formation of a new planetary system once things have settled down. Furthermore, if the exoplanet contains significant amounts of carbon dioxide, this method will be able to detect it. While discovering that molecule will not be a sure sign of life, it will be an encouraging finding worthy of further investigation. Thank you for watching the video.